We're going to look at number 6 in section 2.5. Going to evaluate the limit if it exists, and this is the limit that we're given. If I plug in directly to see if it's continuous, obviously it's not, because 169 minus 169 is 0, but the square root of 169 is 13, and so up top I get 0. So this is an indeterminate form. This doesn't mean the limit does not exist. It simply means, basically, if we look at it graphically, we've got a hole in the graph. We need to find the y-coordinate of that hole to find the limit. And we can do that algebraically. And the trick here is to rationalize rather than numerator. Got this radical up here. We're going to get rid of the radical in the numerator. We're going to do that by multiplying by what we call the conjugate. So remember, if I have the square root of a minus the square root of b, for instance, the conjugate would be the square root of a plus the square root of b, right? And the neat thing about conjugates, if I multiply them together, that will get rid of any irrational values, any radical values. Okay. Now, up top, I've got the square root of x minus 13. So all we're doing is changing the sign either from minus to plus or plus to minus. Since this is a minus, I'm going to multiply the top by the square root of x plus 13. Of course, I can't just multiply the top by that. I have to do the same to the bottom. So the net effect is I'm multiplying by 1, right? This quantity is 1. So when I multiply across the top, I have to FOIL square root of x times square root of x, that's x. The outer term would be 13 square root of x. The inner is negative 13 square root of x. So the outer and inner are going to be 0 when we add them together. And that's the whole point of doing this. The last is negative 13 times positive 13. That's a negative 169. Now down below, I'm just going to leave these things factored. I'm not going to FOIL this out. I would not FOIL that out because you want it factored. And in fact, you can see we have a common factor of x minus 169 in the numerator and in the denominator. So I can divide top and bottom by that quantity, and I'm just left with 1 up top, square root of x plus 13 in the bottom. Let x approach 169. I replace x with 169. The square root of 169 being 13 gives my limit to be 1/26. So that is the limit of the original expression. Don't forget, you can check and verify your limit numerically just to confirm, and that would be a helpful thing, especially on the test, to make sure you're not making mistakes. Okay, I hope that this is, again, helpful on this one.